Hi, I'm JC the Dev, and welcome to my YouTube channel. In this video, I'll be sharing an exciting project where we'll be controlling an LED using a push button and an ESP8266. We'll be using the Arduino app for this project. It's a fun and beginner-friendly Internet of Things, IoT project that demonstrates how we can interact with physical devices using a microcontroller and wireless connectivity. So let's get started. Project overview. Our project focuses on creating a smart LED control system. We'll be using an ESP8266, which is a versatile and cost-effective Wi-Fi-enabled microcontroller. Alongside that, we'll need a push button and an LED. The goal is to wire up the components and program the ESP8266 to toggle the LED on and off when we press the push button. To begin, we'll put our ESP8266 on our breadboard, and then we'll put our push button and connect it to one of the digital pins on the ESP8266. We'll also connect the LED to another digital pin. It's important to include current limiting resistors to ensure safe operation of the LED. We'll set up the connections on a breadboard, ensuring all connections are secure. Moving on to the software setup, we'll be using the Arduino app for this project. We'll write the code that will be uploaded to the ESP8266 to control the LED. The code will continuously monitor the state of the push button. When the button is pressed, the code will toggle the LED state accordingly. To do this, go to Play Store and download Arduino app. Code explanation. Let's take a closer look at the code. In the code, we define three variables: BTN, LED, and status. These variables represent the pin numbers for the button and LED, as well as the status of the LED, on or off. In the setup function, we set the pin modes for the button as input and the LED as output. In the loop function, we use the digital read function to check if the button is pressed. If the button state is true, meaning it's pressed, we toggle the status variable using the logical NOT operator. This means if the LED was previously off, it will turn on, and vice versa. We then use digital write to update the LED pin with the new status. To prevent rapid toggling of the LED when the button is held down, we use a while loop. Inside the loop, we continuously check if the button is still pressed using digital read BTN. As long as the button is held down, the loop will continue running. Once the button is released, the loop will exit. We also add a short delay, 50, at the end of each loop iteration to debounce the button. This ensures that we don't detect false button presses due to electrical noise or bouncing contacts. Now just click Save button, then compile your code, and lastly connect your ESP8266 microcontroller with your USB connector, and then upload the code. And there you have it. We've successfully created a smart LED control system using a push button and an ESP8266 microcontroller. This project demonstrates how we can leverage the capabilities of IoT and wireless connectivity to interact with physical devices. I hope you found this project interesting and informative. If you did, please like this video, subscribe to my channel, and leave your comments and feedback below.